The sixth and final module in this web training focuses on construction of the FAST-14 project, the actual construction. Again, the presenter is Kevin Lampron Jr., Area Manager with J.F. White Contracting Company in Framingham, Massachusetts. Kevin, we'll turn the screen over to you again.
How's it look? We have it on?
Looks good.
Okay. Good afternoon again. The first couple slides that you see may be a repeat or similar to the ones you've seen before. But basically, I'm going to try and focus a little bit on the construction aspect of the FAST-14. And again, this was the design team that I introduced earlier. Kind of a look at the location of where these 14 bridges were on a stretch of 93 in Medford, Mass. And basically, we actually did the northbound side first, and then we switched over for the second half of our 10 weekends and did the southbound side. Just if I back up there a second, you can see, and I just want to point out just how densely populated this area is, and there's very limited access, and there's really not much of any areas to stage and work of on I-93. So, you know, a lot of what we did during these weekends had to get trucked in, and you know, in a parade of sail, we called it, down the highway from our yard in Winchester to facilitate each one of these weekend work windows. Just again, a brief summary of the schedule. Conceptual, August, October 2010, the bidding through December 2010, selection and award January 2011, and then basically, which resulted in our award, design, procurement, construction, and such in February through October 2011 for the bridges. Safety. So on the construction side of safety, basically, just like I showed you in that picture, which is important, you've got the public part of it. When these weekends actually started happening, and we were kind of surprised, is because usually you'll get your sidewalk superintendents, but basically we have residents, we had sidewalk superintendents, residents, we had families pull up on a Friday night, pull out lounge chairs and sit down and have a sandwich and watch us do our work through the weekend. So safety just in the immediate vicinity around the limits of the project were always a concern. Access, like I showed you earlier, we got some big precast units, large cranes. Not all, you know, some of our work was done from the local streets, and not just from I-93. So access and traveling through these congested residential areas was a concern. And some of these bridges that we had a demo were adjacent, pretty close to adjacent existing residential structures. And you know, you'd be out there at on a Friday night from midnight to 6, and you're hammering away doing some demolition. It wasn't always pleasant for some of these residents. Cranes and heavy loads. Like I said, some of our hydraulics we had down on local streets, and you had to be concerned with existing local utilities, overhead power lines, and other utilities, and again, access to get these pieces of equipment to where they needed to go. Our emphasis on fall protection paid off. During our 1 week in operation at the Mystic River Bridge, the worker lost his footing, and he was saved from serious injury because he was properly tied off in a harness, and the work was stopped immediately. The worker was retrieved from a dangling by his harness over the Mystic River. We had an all-hands safety meeting, and basically our procedures worked, our recovery worked, and it's a near miss, but it can certainly bring a dose of reality, and a new perspective on safety to all the guys that witnessed it. White Key self-performed, and we successfully worked about 130,000 man-hours, not including our subcontracts, with no lost time accidents and no recordables. And that's an amazing achievement for what was accomplished. And and it was a compliment to the entire team. In fairness, we had a couple people that had a knee injury and a shoulder injury, but that never resulted into anything substantial. In preparation of the weekend diversions, the existing substructures were structurally evaluated and upgraded to receive the new superstructure and extend the service life of the bridges another additional 75 years. So basically, in the top right-hand corner, you can see where we had to go in and start doing some substructure repairs. And basically what we did was we had some 200K shoring that we had to install. We put that underneath your individual girders in the locations where the new bridge pedestals, bearing pedestals were going to go, or where there needed to be some repair. And we would have to de-lead the existing structure, cope the existing stringers, and then go up and do our repertory work, drilling, installing rebar, placing the pedestals, and performing that work all prior to the weekend of the bridge replacement. And at the same time, you would be pouring these pedestals. You need to give those pedestals sufficient enough time to cure. In addition to that, you can't see it on these pictures, is that we had some early removal of the bridge parapets and the median sections up on the roadway, where we would take the bridge parapets off and put some precast barrier up there in a temporary condition. And then we would also, on that middle picture, we would see the new pedestals and the existing pedestals. We would actually, so they didn't get damaged through the construction and the demolition part of it, we'd have put some demolition shielding around those to try and protect them. And out of the 14 bridges, I think we had one minor infraction with the bridge, with one of the new bearing pedestals that we had to go back and repair. All in all, we had about 1,008 bearing locations. We had to go out and lay out each one of them, develop traffic and work zone plans on the local city streets to be able to get in there and perform some of this work. Shoring design and approval, lead abatement and copes at 624 locations, and we had to put 835 new pedestals in. Pre-planning for material procurement. So this is basically one of our composite sections. You can see the steel girders, stringers rather. They were actually taken in down in Maryland by Structal at their Point of Rocks location, fabricated, and then they were shipped from there over to Jersey Precast, and then Jersey Precast actually did the composite section and poured all our individual pieces. Altogether, we had about 504 steel plate girders, 252 composite precast structural deck modules, basically the precast bridge units. Talk a little bit about our weekend work. So we kind of went through, in a nutshell, I gave you an idea of what happens during the week. In those previous pictures, in 3 slides doesn't tell the whole story. There's a lot of work that had to happen during the week to facilitate this 55-hour weekend work window. And basically, you would be finishing with those 14 bridges. You would be basically a week ahead, sometimes 2. In advance, you would complete all your prep work for that following weekend's bridge, and that kind of followed through the whole job. So on the weekend, 55-hour weekend work schedule basically involves 7 major activities, each with a duration of anywhere between 4 and 12 hours. And basically, this outlined in a very, very general way our traffic diversion time frame, our demolition, our precast erection, formwork and rebar, concrete placement and cure, pavement and milling, traffic restoration, and each bridge itself. So right now what you're looking at is a pretty simple bar chart, but in reality, each bridge had an independent schedule on an Excel worksheet that basically had about 600 lines of detailed activity for each weekend. We broke those schedules down into individual work activities with half-hour increments of duration throughout the weekend. And we did that Then we distribute it to Mass DOT and the Mass State Police weekly. And in that, it included the entire roster of personnel, including craft, equipment, subcontractors, work activities, durations, emergency contract numbers, and it identified the trigger points along the weekend where if we hadn't reached a certain point, we would have to implement our contingency plan. So here's a take first look at our traffic, and diverting traffic. It's the first activity in our 55-hour work weekend window, and we had to divert traffic on both local and mainline I-93. This is actually a look on the southern limits of the job, looking obviously towards Boston, where we are diverting traffic to the northbound side to facilitate work on bridges to the southbound side to facilitate work on the northbound side. Here we see that the movable barrier lane has been deployed, and it is restricted to 2 lanes southbound and 2 lanes northbound. And basically that was performed utilizing a state police rolling roadblock that enabled crews to place traffic barriers throughout the transition into the 2 contraflow lanes. Hard to see in a picture like this. But then after that, the northbound traffic is then diverted into the crossover, allowing all 4 northbound lanes to be closed for bridge demolition and replacement. Some stats that I think you heard in some of the previous modules is I-93 has an average daily traffic of about 200,000 vehicles. Peak demand is about 5,500 vehicles per hour per direction. In our implementation of our traffic controls to support weekend work, you'd have to implement 22,000 feet of zipper barrier would have to be moved. 2,200 feet of temporary markings would be put in, 1,500 drums and cones, 15 message boards, and 7 TMAs. And we needed to do this to reduce the travel through the work zone by 40%. So basically, your track diversion, we talked before, you've got the crossovers, the zipper lane, rolling roadblocks, and local roads. And basically what you see here is the State Police Incident Command Center. So on Friday night at about 6 o'clock, before the weekend actually started, there was one location that's basically in Medford where we parked the Incident Command Center throughout the project. And then we would collectively man it. Mass DOT would have a person in that command center 24 hours a day, through the weekend, from Friday night till Monday morning. White Kiwi would have someone in there. The state police would have it manned. There would fire departments from both Somerville and Medford would have it manned, and emergency response professionals would be in there. So basically, should anything happen, as part of our contingency plan was to be able to have that ready to respond to just about anything that could happen that would impact a job and the interstate. We accomplished these traffic diversions by basically, I talked a little bit earlier about implementing these 2 1,800-foot crossovers, one at the northern and one at the southern extremities of the project. So if you look at the screen, you can see I outlined them with where the crossover locations are with the 2 red dots. And basically, there was about 5 miles in between them. Nighttime view of the barrier deployment going on. You can see both of the vehicles. The first one, which is ahead of you in the center of the picture, is moving the barrier out 1 lane. And then you have the second following behind it, moving the barrier out to the 2nd lane. And this, I believe, is actually looking again into Boston. And this would facilitate, in this case, would be a northbound shutdown. You can see all the barriers, you can see all the cones, you can see the barrows and how this all gets laid out. On the left-hand side of the picture, you can see that, and we didn't have any good pictures of it, but prior to the implementation of the zipper lane, we would be doing bridge replacement at basically 2 bridges every weekend. And each one of those bridges could have up to 18 pieces of precast, of the precast bridge units. So we had to take those pieces from our yard in Winchester, what we call the parade of sale, in conjunction with Mass DOT and State Police. We would escort them down from Winchester, and then we would strategically place them on wherever they needed to go, so that you can see here we parked them on the northbound side, getting ready for when the traffic shift happens. Then the traffic shift, everybody will go over to the southbound side. Then we'll move those to another location to be able to support installation of and have access from the cranes to be able to set those pieces in place. That all has to get done prior to demolition, because once you demolish and remove that section of I-93 North, I no longer really have any way to get those pieces to the locations they need to be placed. This is the northern crossover, an aerial view during the day. And again, this one here is basically looking south, and I believe, and this facilitates a southbound bridge replacement scenario. This is the demolition phase. So we set up our traffic now. We just showed you how we do that. We got traffic all moved over, and now we're able to go to work and start our demolition. You can see that this happens to be Route 16 on the top picture, where you see that the multiple pieces of equipment. And demolition is commenced there, and this is the first thing we do at night, and basically it starts anywhere from, right after we get that traffic set up, somewhere around 9, 10 o'clock at night, these pieces of equipment moved in and they started the demolition. You can see we've got water and dust control, multiple pieces of equipment. Shut the local street down. That's Route 16, I believe. We shut that down to be able to facilitate this demolition. You can see all the shoring that's up to be able to support the existing girders, stringers, and you can see the protection that we put around, some wood protection around these bearing pedestals. This is what it looks like basically in the next morning. So you come in Saturday morning, and the demolition has basically been complete, and you're ready to go into your next phase. So we're moving in with our carpenters and our laborers. We're pulling our shoring out of there. We're stripping the bearing pedestals, and at the same time, you've got the demo subcontractor, and then he's basically cleaned up, but he's doing some finalized cleaning up. Our cranes will be showing up on site, and they'll be starting to mobilize and get ready to receive precast. On the bottom right hand, you can see the bearing pads installed on the new bearing pedestals. On the back wall that was talked about earlier, you can see that in this case, you have demo up into that back wall. So we'd come in, we would set the girders, we would do our form work, and this section that you're looking at right here actually gets formed and poured in conjunction with the deck, the closure pours on the deck. Transport of precast. It's basically, we needed about 252 permitted loads, coordinating the precast sequence. We tried to have our precast here delivered 1 week prior to setting. There was specialty transport that needed to get done. All this stuff came up from New Jersey, and all it had to be coordinated with the Mass State Police to get it where it needed to go. All these pieces basically, I think the longest piece was about 105 feet long. You can see in that bottom picture where you got the bay crane, the steerable dollies that were required to be able to move these things and facilitate the access to streets and city streets. But those particular specialty steerable dollies, what we found out on this job is they're not readily available. We actually had to bring trucks in from the Midwest to supplement local and down in New Jersey to be able to supplement what was available in this area. And just like I talked a little bit earlier, we had a parade of sale where these you'd have up to 36 pieces of these coming down at night around 8 o'clock, being able to and park them on the side of the road until they were needed. So now you got precast direction, the precast direction phase. So now our demo is done, and basically our precast is here. Basically, this picture, as you can see how tight these lifts were planned. You got an operator looking straight up at the load, and he's probably got less than 2 feet of clearance from the boom height to the boom hoist cylinder. This was done to minimize the crane moves, which took an average, because each crane took an average of 2 hours just to move one of these large hydraulic cranes. You had to take the counterweight off, you had to have a place to store it, and then you would basically have to move your crane and then rebuild your crane all over with. And to avoid that, we engineered our picks pretty tight. So you can see in this picture that this is actually that Route 16 that we looked at earlier, which was basically one of our largest spans. Talked a little bit about safety earlier, but crane layout and staging was, and again, Mike and I think Joe both talked about this, but this looked at all kinds of cranes and what was best to be able to utilize and would work for this project. And we ended up at hydraulic cranes. Some of these lattice boom cranes and crawler cranes just ended up not being practical. But every pick that was performed on the job had a crane layout and staging, and it had a pick plan, and it was reviewed and engineered and stamped to make sure that we tried to iron out as many of the unknowns as we possibly could. We looked at what the existing where the crane pads were going to set, if there were utilities underneath it, what the bearing pressures were going to be, what kind of ground bearing we were going to be looking at to set this crane on. More of the precast direction phase. So after I told you that we went to hydraulic cranes, you can see here that there was a couple instances where we used a lattice boom crane, only because it made sense for that particular bridge, which was Route 16. You can see some different cranes. You see the hydraulics in the middle picture setting a piece, and up in the top right-hand corner, you can see some of the access requirements. And just like I told you earlier, if you go over on the left, there are some yellow shirts there, but you can basically controlling the public was from, because they just wanted to watch, and was also a concern. So Mystic River. So Mystic River basically spans. It's you got the center span, you got 2 back spans that span over the Mystic River. So we didn't think we could accomplish that all in one weekend. So what we did was decided we were going to do it in 2 weekends. So we went in, and during the first weekend we demolished the center span, and basically what we did was build the permanent center span on jacks, and left it basically high so that we could let it match the existing profile on both of the back spans. And then we came back the second weekend, took both back spans out, and then built the back spans, and then we lowered the jacks on the center span to be able to get this to the right elevation so that everything could marry together. You can see the barges in the water, in the center picture, which we utilized for formwork and staging the jacks and for the jacking operation. So after my precast is set and we get into the forming and the reinforcement, so I talked earlier about doing mock-up drills. The precast, while it was in our yard in Winchester, we tried to attach as many components of our formwork as possible to the underside of the precast. We knew how we were going to form this so that when they were making the precast, we had them install BBSs and such, and so that we could attach our formwork system to the bottom while it's in the yard. And then once it got on site and it got set, we could just loosen that up and swing it into place, drop in your plywood, and then start your reinforcing steel. And in this picture, you can see that you've got, you've got these backspan pieces set. You've started your formwork. Your iron workers are installing rebar. And on the back of the picture, looking away, you can see they're a little bit behind on that side. They're setting their precast and going to start those same operations. And then these operations would chase the center span into the night to get complete. This is what it looked like at nighttime. Setting the last piece of precast. You can see the rebar is in. You can see the formwork done basically on both sides, and we're waiting for the final adjustment on that precast to be done so we can suck up our forms to the underside for the closure pours and finish our formwork and rebar operation. On the ultra-high performance concrete, the mixed design, development, and testing. Performance criteria, just like I talked about before, was provided. And where we had to reach 2,000 psi within 4 hours of final set, and we were successful with our testing program doing that. And then we did the mock-up up in the yard, so that when it came time to do this out in the field, on live time, at least we had an idea what we were up against. And we used the curing compound we used on it, plus we ended up using some plastic on top of it on the curing to try to eliminate and reduce the cracking. So our concerns during the ultra-high performance concrete was basically going through this process in the beginning of trying to find out what mix it was going to be able to put together to make it work. So we actually ended up doing 42 test mixes before we come up with one that actually worked. And then we went through a couple trial batches on them test mixes until we end up with one approved mix, and that met our objective. So we had an independent testing lab there during the weekend, so we would basically, that would move in on a Friday night. It would be calibrated each time we moved it. It was self-sufficient to be able to give the compression tests and all the other tests required to get approval on site to be able to put traffic on the concrete. We had it done by an independent testing agent that was AASHTO and NETSIP approved. I took the concrete temperature, air, and slump, and then the compressive strength. Well, you can see them making the cylinders in the picture, and on the bottom, basically you can see the little show that was there when they tested cylinders from each truck. Every truck got tested before it was released to go and be placed in the closure port. This is a look at the closure port placement. This is in one of the beginning bridges. We actually built some ramps for the trucks to be able to span these closure pours as we learned. But you can see in this picture where we're shooting it into the closure pour and placing the concrete. On top right-hand side, you can see him spraying the curing compound. And in the bottom left, you get a good view of the plastic that we put over it to try and keep the moisture in as it hydrates. And then the guy's placing the concrete. So during Joe talked about it earlier, talked about our waterproofing of the bridges. So this operation, you can see, happened concurrently while we were doing bridges. So I had, basically I would shut down the northbound or the southbound side. We would have two bridges going concurrently with demolition and bridge replacement. And then concurrent with that, we would be at different locations along the job. And if, weather permitting, we would be doing some waterproofing, the 3-coat waterproofing system that Joe was talking about, spray applied. You can see the barriers that we're putting there for the permanent barrier installation. We'd have to form those and pour them because there is no precast TL5 barrier. And this would all happen concurrently while the other two bridges were going. You can see the traffic, 2 lanes of traffic going both ways on the other side. So you've heard me talk enough about it. I'm going to try and show you a little video here of what it looked like performing this work actually at night. So you can see this is about 9 o'clock at night, and we're doing one of the smaller bridges here. Our subcontractors in there doing demolition and basically taking the concrete deck off. And then we have a machine down on the road that's picking and removing the steel. And this happens all through the night. Concurrently, he's down there and he's taking his demolition, loading it into trucks, and hauling that off the job. This is actually looking north, I believe, on the northbound side of I-93. You can see where the orange on the piers and the abutments is where we've done the protection on our new bearings locations. The cranes are coming and getting set up now for precast. Iron workers and carpenters are in, setting up access, stripping. You can see up on the top left-hand side of the picture where we have stored against the median all the precast that's going to be set by that far crane. Precast is starting to be set. And you can notice the amount of craft and the amount of people working on this single bridge. Bear in mind, there's a second bridge going on concurrently with this, with the same similar operations and the same amount of people. Right after the precast is set, you can see the formwork going in and starting to put in our rebar. This is a good day, actually. It was a little damp out, kept the dust down. Last piece of precast gets set. Now we're into Saturday night, finishing up our precasting and our formwork. A little bit of rain. And then get your iron in, start cleaning up for the concrete. Probably about the middle of Saturday night now, early Sunday morning. Here's your concrete trucks coming in. We start placing concrete, shoring, and putting our plastic down. Sunday morning, completing our concrete placement. It was a good day. Now we're cleaning up the both sides, getting everything ready. You'll see coming in now doing our milling and whatever other preparatory work we had to do from a grade perspective. Now we're sitting there letting this closure pour get up to strength. No traffic's allowed on it yet. There you go. We must have got a approval. Then the traffic's allowed to go back and forth. And basically at the end of the weekend, the only thing you don't see here is that we would put our temporary barriers out and restripe that roadway and open it to traffic. So lessons learned. I could never say enough about the combined team effort that it took to be successful on Fast 14 from Mass DOT, FHWA, and again, and I know Joe and Tom and Mike would say the same thing, is that it was unprecedented cooperation in trying to meet this, and everybody was bought in to make this happen. So we got to have that. We got to have communication. We got to really look at site logistics on some of these projects, and I think Tom and Mike mentioned it earlier. Is why is one job good for this kind of method and not and some aren't? All these things have to be looked at. Pre-planning the work. That was my previous module. None of that's possible unless you have successful pre-planning. Equipment resources. 600, 700-ton hydraulic cranes aren't just sitting there waiting for you to to get your hands on. You have to reach out and plan your work, and these cranes are, they're getting more readily available because we're getting into larger cranes everywhere here. But finding these cranes and having one on standby just in case you have a problem. And then your equipment resources as far as, like I talked about, the precast being trucked up from Jersey and having to go out Midwest to get steerable dollies. And permitted loads across straight lines. I didn't talk about that when I talked about the precast. We had some issues where bringing these large pieces of precast up, and trying to get them here in a timely fashion, for a Friday night. If you couldn't get them there the week before for whatever reason, sometimes they get caught in Connecticut or they get caught in New York or Rhode Island because they're the different permits that are required. And that, we actually had some significant problems with that almost cost us a couple weekends. On this last picture for questions, you can see this is our showcase weekend that we have with FHWA. But basically, we did 2 bridges concurrently right beside each other at the Salem Rotary. That's a pretty good picture of what we had going on at the same time and what it requires to get that job done. So if there's any questions, I'd be happy to answer.
Thank you, Kevin. No questions have come in. So we're now at the end of the 6th and last 40-minute module. Thanks again to you, Kevin, for both of your last 2. And this completes the first in-depth web training for the FAST-14 project sponsored by the ABC-UTC. Thanks again to Tom, Mike, Joe, and Kevin for sharing your expertise with participants in this web training. Thanks also to all of you who participated in the web training. The web training is now ended.